Hello there, what's up everyone? How you doing? This is a follow-up video, part 2 of Egan fundamental respiratory care. This is gonna be on chapter 6. I did the first video, the first part on this chapter. So this is the second part. We will be picking up on where we left off. And I would like to thank everybody for watching the first part. I hope you guys was you helped yourself from watching it. I hope that you learned from it. And this is the point of this video, is to make you understand. Also, it's a way to learn how to study, because not a lot of people show you how to study. Everybody just tells you study, all teachers, but some of them do. We have a lot of great professors, a lot of great teachers who put the effort on that. But again, I want to thank everybody that watched. I want to thank everybody that put a comment. So we will be picking up where we left last time. I'm just going to zoom in a little bit with this video so that way you can guys see a little clearer, be a little better. Just adjust the camera. Hope this helps a little bit. It looks a little clearer to me. Just going to adjust a few more. There we go. Alright, so we're going to be picking up where we left last time. So we don't need this. We'll need some pen, pencil. And what I want you to do is make sure you get a blank piece of paper. That's where you're going to take your notes. And you're going to study from off of these papers that you're going to take. So we can start with chapter 6, Physical Principle of Respiratory Care. Okay, yeah, the last time we left off, I believe, at internal energy of matter. Okay, so most likely this chapter is all going to be about physics. It is very important. It is the fundamental of physics to understand in respiratory care. The reason why is because you need to understand how the lung works, because basically everything has a law. Physics goes into everything that we do in respiratory care. So again, if I were studying, I will continue from here. Internal energy of matter, right? The atoms that make up all matter are in a constant motion at their normal temperature. This motion is returning from internal energy. There are two major types of internal energy: potential energy and kinetic energy. So the first thing that you do is you understand that there's two types of energy. So if you don't know it, this is what you will do. Every sentence is important, every paragraph is important, every word is important. So here it tells you the atoms that make up all matter are in constant motion at normal temperature. So here we have a key here. At a normal temperature, the atoms, which is the small pieces that is in each matter. Matter could be anything that is a solid, a liquid, whatever it is. Matter, anything that occupies space, right? So this pen is a matter. This paper, this chapter, anything, the phone, your computer, whatever. Oh, one more thing to point out. When you study, make sure you have a computer next to you. The reason why, if you have it, if you don't have it, it could work. But the reason why is some words or some topics you might not understand from a chapter. So you would have to look it up like in a YouTube website or in any other websites. But it could be a disadvantage to have a computer next to you, because you might stop, you're focused on learning and then just go straight to the computer and start playing with the computer, go to different sites from here, then you spend a lot of time and you didn't even study. And in respiratory, you need a lot of time to study. That's the way to do it. That's the way to be the best. That's the way to be the best at your job, understanding everything. And let's stay focused and continue where we left off. Okay, so now we said the atoms that make up all matter are in constant motion at the normal temperature. This motion is resulting from internal energy. There are two major types of internal energy. So here we go. We have two types of energy, the major ones. So we're gonna highlight this. We're just gonna underline it. So potential energy and kinetic energy, right? Now this paragraph is gonna continue explaining what is potential energy is referred to as the energy of position that is object balanced on a shelf. So anything that is stays, so they're saying that, let's say this pen is right here, it has a potential energy object like on a balance on a shelf, right? So anything that is sitting on a shelf or anything that is sitting anywhere, that is the potential energy it holds inside, the internal energy of it, right? And then it says potential energy is a result of the strong attractive forces between the molecules. Now, those are molecules, right? Right over here, you see it? So any force between them is the potential energy that gets them together, right? These intermolecular forces are why solids are rigid and liquids have viscosity and cohesiveness. These same internal molecular forces are not as strong in gases. Kinetic energy is the energy of motion, such as falling object. Most internal energy is gases in the form of kinetic energy. So here you need to point out most internal energy in gases is in the form of kinetic energy. So kinetic energy is movement, is an energy that is being moved. So gases, when you see, like if you look at the figure here, gas sinks. So you see the movement of these molecules or atoms, right? So anything that is in movement, you're gonna remember kinetic energy. Anything that is not in movement but it has the energy is potential energy, okay? Then you're gonna move on to laws of thermodynamics. The term thermodynamics can refer to either science studying the properties of matter at various temperatures, of the kinetic speed or reactions of matter at various temperatures. From the study of physics, we take the special notice of the law of thermodynamics. The law describes how fundamental physical quantities, temperature, like temperature, energy, and entropy, behave under proportional motion, right? So this is all gonna explain about laws of thermodynamics. Heat transfer, conduction. So these are very important topics in thermodynamics. Heat transfer. So how these energy transfer, right? So when two objects exist at different temperatures, the first law of thermodynamics tells us the heat will move from one hotter object to a cooler object until the object temperature are equal. This is an example of transitioning from a higher state of energy to a lower state. Two objects with the same temperatures exist in thermal equilibrium. Heat can be transferred in 4 ways. So they're saying here, heat can be transferred in 4 ways. So this is very important to understand how heat transfers. And those are the 4 different ways: conduction, convection, radiation, and evaporation, and condensation. So we all understand. So for this to understand, all you need to know is these 4. That will tell you about the laws of thermodynamics, right? So it says here, conduction, heat transfer, and solids occur mainly in conduction. Anything in solid transfers in conduction. Conduction is a transfer of energy by direct contact between hot and cold molecules. So here, conduction, you need to understand it. Heat transfer between two solid objects in direct contact, right? So, direct contact, right? I'll show you what's direct contact. You have this pencil and you have this pen. Let's say this pencil is like is 50% hotter than this one, right? So this one has more heat, this has less heat, right? Less, like this one has 50% of the heat of which this one. And I'll put it in another way. From 1 to 10, this pen is hot 8. From 1 to 10, this pencil is hot 10, right? So in direct contact, if you put them together like this, wherever is the hottest is going to transfer to the other one until they reach equilibrium, until they're all equal with the same temperature. Okay, so this is conduction. Heat transfer in solids occur mainly via conduction. So in solids mainly, right, it goes through conduction transfers. Conduction is the transfer of energy by direct contact between hot and cold molecules. Okay, so it has to be direct, it has to be together. Okay, how will heat transfer by conduction depends. Okay, now they're asking you how well will it transfer. Okay. So on both number and the force of molecular kinetic. Okay, between okay, you don't need this. Heat transfer between objects is quantified by using a measure called thermal conductivity. Okay, so there's a measurement for it. Then you have convection. Heat transfer in both liquids, gases occurs mainly in convection, liquids and gases. Okay, so this is important, right? So we already says conduction, right? This is how it write this, but I'm gonna put it on the chapter so when you go back and review it, it's better for you to understand. So we already said conduction is one type, right? So conduct, and then you're gonna put solids. So mainly any topic they talk about conduction, just see what they're talking about with solids, right? Convection, you're gonna put convec, and you're gonna put, like they said here, mainly liquids and gases. So we're gonna put liquids, right, and gases. All right. Then you're gonna continue reading radiation, because I'm just almost like going through it fast, is because I don't want it to take a long time of your time. This is the main point of it, is to make sure that you understand how to study and how to keep. But again, if you're studying, you're gonna be reading all of it. So if you look at this chart right here, thermal conductivity, this is important to understand, right? So they're saying thermal conductivity, the highest is 1, which is silver, copper, iron, lead, and then it goes all the way down to air. Okay, so it's important to understand this. And then it goes to radiation, is another mechanism of heat transfer. We already know that one, radiation. Then you have evaporation and condensation. Those are very important in respiratory care. You need to understand them, because there will be questions about you know, the oxygen tubing and all that stuff in the mechanical ventilator. Also, if you are working in clinicals, and then sometimes but they have now heated circuits now, it's better, because not a lot of condensation happens, but it usually happens in the old tubes, the corrugated tubes, where you will see some water is in the tube, so you have to empty it out. And but you might not face it nowadays. It's all heated tubes, not all, but it's that's the way. So it has to do with condensation here. Then temperature, absolute zero temperature scales, you need to go through that. And then change of state, liquid, solid, phase changes, melting and freezing points. You need to understand these points here. Okay. So again, every topic we see it here, and then you will see where it's a change of state. I would recommend that you study each topic on its own. Again, all this is just, you have to read it, make sure you understand it. Anything you don't understand, you can always put a comment below or email me directly and ask me if you have a question on chapter 6. But that's basically it. I don't want to focus too much on chapter 6 because it's all about physics, and respiratory care has to do with physics but not too much. And we will be moving on to chapters. You guys, if somebody is right now in respiratory care, we want to help you. So if you have a next chapter that we want to go to, something you want to, topic you want me to focus on, put a comment below or send me an email and we will focus on it. So I'm basically doing this channel to be like a tutor that I can help anybody who's studying respiratory. And first of all, I want to let you know that I am a respiratory therapist. I'm currently working right now. I've graduated not too long ago, and I want to help to see if somebody is struggling. Anything is doable, and in respiratory care you need to make sure that you study hard in any field, not just respiratory. Any field you study hard. Everything takes time. Nothing is easy, but you'll get there, and when you get there, it's sweet at the end of the tunnel. And if you have any questions about being a respiratory therapist, if you have questions about how will I find a job, or about the salary, or about how difficult is the job, anything like that, put in a comment below and I'll put a video to address all of your questions. Thank you very much, and have a wonderful day or evening or whatever is at current time that you're at. And thank you very much. It was a pleasure for me to put this video up. I didn't give a lot of information in this video, but this is what I could give today. And thank you all for watching.